This is a help video for the 6.12 unit test part 2. 6.12 unit test part 2. If you are in regular Algebra 2, you only have 2 TGAs per semester. So you had a Unit 2 TGA from the first 9 weeks, and then this is the Unit 6 TGA from the second 9 weeks, and then you'll have 2 more after Christmas. So if you're in honors, you know that you have at least 1 per unit. This is the exact 6.12 questions. I have added a Desmos graph on top of number 1 and number 2, and then I'll just kind of talk about some formulas for number 3. But on number 1, it says use the space provided to respond to each statement concerning the given graph of an exponential function. So let me pull up my draw tool. A is asking me for the domain of my graph. I know that domain are my x values, and I know x values go from left to right. So this graph fills up the window, and again, this little piece that you see is the graph that's actually on the original number 1. But so this graph continues at the end of the viewing window, so we know there's an arrow there. Always like to look for arrows first. This graph goes to the end of this viewing arrow, so I know there's an arrow there. So when we're talking about domain, we're talking about x's. So this graph goes forever to the left, and it goes forever to the right. It is continuous, meaning it never stops. So we know that the domain goes from parentheses, negative infinity, to parentheses, or comma, positive infinity, parentheses. You could also say all real numbers. If you want to just write out the answers to these on a sheet of notebook paper and not have to fool with finding symbols for infinity, you can just write number 1, A, parentheses, negative infinity, comma, positive infinity, parentheses. That's your domain of the original number 1. And just write your answers out. Take a picture of your work and submit your picture. That might be easier for some of you. B, 1B says range. We know that range are our y values. Y values go up and down. So this point is at -2, this point is at -4, and this graph has what we call a horizontal asymptote. So it's bending towards this imaginary horizontal line. And if we were actually in Desmos, we could zoom in, and this graph is never going to touch where y is equal to -3. It's considered a horizontal asymptote. So this graph goes, how low does it go to how high does it go? So it goes almost to -3, but doesn't touch it. So that's why we use a parentheses instead of a bracket. And then it goes up forever and ever. So that's to positive infinity. So our x's go forever left, forever right, negative infinity to positive infinity. Our y's go all the way down to -3, but don't touch -3. That's why I'm using a parentheses, not a bracket. And then the graph goes forever up to positive infinity. Is the function discrete or continuous? The graph is connected in all areas. There are no stopping points, so that makes the graph continuous. I don't know why I have trouble spelling continuous, but I do. And then don't forget it does say explain, and I would say something like no stopping points. You can say all parts of the graph are connected. D says identify the y-intercept. So we're going to find where it crosses the y-axis, and it does say use an ordered pair. So that would be at 0, -2. E says, is this an example of growth or decay? So just a quick example, if your graph is increasing from left to right like this, that is an example of growth. If your graph is decreasing from left to right, levels off, that is an example of decay. So this graph is increasing from left to right, so we're going to say growth. And then it says, how do you know? And I would just say increasing from left to right. You could say as x increases, y increases. A couple different things that you can say for that. Number 1 is worth 5 points, so you get a point for A, B, C, D, and E. Just make sure that you read the question and you look at the graph that is given to you for number 1, because this is just a different graph, same set of directions. All right, number 2 says use the space provided to respond to each statement concerning the given graph of the log function. Again, 2A is asking us for the domain. That means the x values. That's how far the graph is going left and right. So again, the graph fills the viewing window, so we're going to put arrows on it. This graph is bending towards an imaginary line that's located here. And that's where x is 1. So we're not ever going to get to where x is 1. We're just going to keep getting closer and closer to where x is 1. But then when we go to the right, it goes to positive infinity. So it's going to be parentheses because we don't have an x that's positive 1. And then it goes to infinity. Our range, again, are our y values. And when we're looking at a graph, that's how low the graph goes to how high the graph goes. This arrow is pointing down to negative infinity. The graph is continuous. This arrow is pointing up to positive infinity, so my range is negative infinity to positive infinity. This says identify the end behavior. So remember, when you're identifying end behavior, your graph always has a left end. So you got to talk about the left side, and you have to talk about the right side. That's something a lot of people, they're forgetting, that there's a left and there's a right. So on the left side, the graph is approaching as the x's approach 1, my y's are approaching negative infinity. So on the left-hand side of the graph, as the x's are getting closer and closer to 1, the y's are going down to negative infinity. On the right-hand side of the graph, as the x's approach positive infinity, the y's approach positive infinity. And you may see an f of x instead of a y, because f of x means the same thing as a y. You can use y or f of x there. D says, what is the x-intercept? Write your answer as an ordered pair. So this graph crosses the x-axis here at 2. That would be the ordered pair, 2 for x, 0 for y. And E says, does this function have an absolute maximum? So a maximum would be where the graph reaches its maximum height. So a parabola is a good example of something, or a graph that has a maximum where it reaches the absolute max. But since this graph is going forever up, it's not going to reach a maximum and then turn back down. So we're really looking for highest mountaintops when we're talking about absolute maximum. So we're going to say, does the function have an absolute maximum? That would be no. And then is it explain why? And I would just say the graph continues to positive infinity, or infinity. Use the symbol or the word. All right, so again, 2, A, B, C, D, E. Each one of those will be 1 point each, because number 2 is worth 5 points. All right, I did not change the last problem because I'm just going to kind of talk about your formulas that you can choose from. This says the population of a town was 5,000 in 2010. The population grows at a rate of 1.4% annually. A says use the exponential growth model to write an equation that estimates the population T years after 2010. So in this particular section, we learned 2 formulas. One of them was growth, and we'll talk about both of them. The one that was growth was y equals a, parentheses, 1 plus r to the x or t. They're using t for time in this problem, so I'm going to use a t. So that was the growth model. And then in this unit, we also had a decay model. That's when something was decreasing. Growth is when something is increasing. The decay model has the formula y equals a, parentheses, 1 minus r to the t. And then I'm going to go ahead and tell you what each variable stands for. All right, y is going to be whatever you're measuring. So here we're measuring population. So y is going to be population. A is going to be beginning population. This could be about dogs or cats or money or whatever, but this particular problem is about population. 1 is in the formula. R is your rate as a decimal. So just a quick reminder, if your rate is 5%, remember to change that to its decimal form, which is move the decimal 2 places to the left. So you would have to use 0.05 or you'll get it wrong. And then T is time. So in this problem, a lot of problems, you have to read the problem and decide whether to use the growth formula or the decay problem. This formula is, it uses the word grow right here, which tells you this is the formula to use. It, in the A part, says growth model again. So that's telling you to use this first equation. And you just have to figure out where to put everything. So again, A is going to be your beginning amount, your beginning population. So you're going to leave the Y in there. You're going to put a number in for the A. You're going to look for your rate. You're going to move the decimal 2 places to the left. You're going to put that number in for your R. And then you've got to figure out, A says use the exponential growth model to write an equation that estimates the population for T years. So this A part, you're going to just plug in the A and the R, and you're going to leave the T because it says in T years. Okay, so you're not going to solve all the way out for the A part. You're just going to put in your A. You're going to put in your A. 1 is in the formula. You're going to put in your rate as a decimal, so you can't use 1.4%. You'll have to take the percent sign off, move the decimal 2 places to the left. You'll put your R in, and then you're going to leave the T. You'll leave the T in the A part, and then you'll simplify that out. You'll simplify. In the B part, you're going to use your formula from the A part, and you're going to estimate the population in the town, not in 2010, but in 2022. So you're going to use this formula. You've got to figure out, the first thing that you got to figure out is how much time, how many years have passed between 2010 and 2022. So this is going to give you a number of years. You've got to figure that out. That's going to be your T. And then you'll put that T into the variable T, and then you'll work your problem out. So you'll use the formula that you got from the 3A. You'll figure out how many years. You'll place that in the T spot, and then you'll work the problem out from there. Okay, I actually think 3 is probably easier than 1 and 2.